Okay, question 5. Quite a big question, but what do we see? We see straight lines, we see a triangle. We should be thinking equation of a straight line. Sure enough, it is. We're trying to work out the perpendicular bisector of PQ. Okay, so the line is a perpendicular bisector of PQ, which means that it cuts PQ in half, and it's at 90 degrees to PQ. So the first thing I'd be doing for that one is saying, okay, well, let's work out the gradient of PQ. So, we usually do point and gradient equation when we do straight lines. And for this one, I want to know the midpoint, and I want to know the gradient of PQ so I can then flip it round. I'll write that in as well. Oh, so just budge over a little bit. So we'll do the midpoint first. So I'll write down the point. We'll do the midpoint first. So I said before, you're going to add your x's and half it, add your y's and half it. So if I do that, 3 plus 9 is going to give me 12. 12 divided by 2. And 4 plus negative 2 give me 2. So 4 plus negative 2 give me 2. And then I'm going to half that. So the midpoint is going to be 6 and 1. So there's a mark for 6 and 1. I'll just put that in. And the gradient, I think actually for this bit I'm going to say that I'm doing the gradient of PQ just to remind me. Okay, the gradient of PQ. But for that one, I will do 4, take away negative 2. y2, take away y1, divided by x2, take away x1. Now you might have wanted to write out all the points. I'd encourage you to do so if you're kind of making a lot of small mistakes, or if you're just a bit nervous, so negative 1. Now this is where breaking down this is quite helpful. So it reminds me, I don't want that. I now want the perpendicular gradient, which is just positive 1. So you change the sign and flip it. So this was a bit easy because you just change it from positive to negative. But don't forget, if you've got a gradient of, say it's a fifth, the perpendicular gradient would be negative 5. Okay, you're flipping it, changing the sign. Don't forget that. And now I'm ready to substitute in. So y take away b is equal to m x minus a. So that's going to be x take away 6. I'll add the 1 to that side. So x take away 5. So you're going to mark for your midpoint. You're going to mark for the perpendicular gradient, and a mark for your final answer. So PGE, not too bad a question, eh? Next question. The equation L2 is the perpendicular bisector of PR. Okay, and it's that. Calculate the coordinates of the intersection. Okay, so not too bad then. So the first one, we're saying we've got y is equal to x take away 5. We just worked that out. And the other line, they're telling me is 3y plus x. So I'm going to call that negative x plus 25. I've just rearranged that to make it the same as this one. Okay. Now that's going to help me out because now I can actually just add these two equations together. Sometimes you've got to factorise them up. Maybe you've got to times this by 3 or whatever. But nope, I can just add them together. So I'm going to get 4y is equal to no x's, and I've got 20. So y is going to be equal to 5. So I'll substitute that in. If y is 5, part 1, I then say 5 is equal to x take away 5, then x has to be equal to 10. So my final answer would be 10 and 5. So simultaneous equations and then substitute back in. So that point in there is 10, 5. Which actually, if it's drawn to scale, doesn't look too bad because that's 9. So 10's a bit over. There's negative 2, 4. So yeah, if it's drawn to scale, that would make sense. And the very last one, equation of the circle. We have not done this in my class yet, so I think I will leave this one out and I will come back and add that one in at another time. But for just now, for my class, that is what I want to get through.